All right, picture this for a second. You've just bought a brand new, massive, double-door refrigerator. It's an absolute beast of an appliance, easily weighing a few hundred pounds, right? Now, think about the delivery workers who have to actually get that giant metal box off the truck, up your front stairs, squeeze it through a narrow doorway, and somehow wrestle it into your kitchen. How do they actually manage the logistics of moving something so heavy and awkward without breaking their backs or, completely wrecking your house? Well, this sets up a really fascinating everyday analogy for what we're going to dive into today.
So, to make it easier on themselves, those delivery workers usually don't try to carry the fully loaded, completely assembled refrigerator right out of the gate. Instead, they strip it down. They take off those heavy front doors, they pull out the glass shelves, they remove the plastic drawers. By doing this, they strip the whole thing down to just its bare main body. Suddenly, the total weight they have to lift and maneuver is drastically reduced. They get the bare shell into your kitchen first, and only then do they reattach all the doors and shelves. Keep that super simple strategy in your mind because it is exactly how the world's top engineers handle lifting some of the largest objects on Earth.
Welcome to today's Explainer. We're jumping straight into a topic called lifting giants and uncovering the very specific, highly crucial secret of erection weight.
Taking that simple household refrigerator analogy and scaling it way up to an industrial level, we come to a foundational term for plant engineers, erection weight. Now, in the plant construction industry, the word erection simply means standing a massive piece of equipment upright and installing it into its final permanent position. So the erection weight is the total, exact weight of an equipment piece at the precise moment it is hoisted into the air by a crane. It's the ultimate number that dictates absolutely everything about how a lift is planned.
You see, erection weight isn't just some theoretical number floating around on a fancy design blueprint. The ultimate source of truth is the actual number displayed right there on the crane operator's digital monitor inside the cabin. When that massive crane hooks onto the equipment and literally starts fighting gravity, the number flashing on that screen, that is your erection weight.
And this perfectly illustrates our baseline scenario. Notice the bare equipment main body being lifted here by a heavy-duty crane. Just like our stripped-down refrigerator, this is a massive piece of machinery, but it is currently just the bare metal shell. None of the external accessories have been added yet. At this exact moment, the crane is lifting the absolute minimum weight possible for this specific piece of equipment.
But here is where the plot really thickens. What happens when the equipment isn't just a relatively small tank? What if our refrigerator in this scenario is actually a towering piece of oil and gas equipment, like a vertical tower that is 100 meters tall and weighs a staggering 1,000 tons? To put that into perspective for you, 100 meters is about the height of a 30-story building. You simply cannot stand a 30-story metal tube upright and then expect workers to easily attach parts to the outside of it.
As it turns out, trying to assemble things in the sky fails spectacularly. Think about it. If you stand a 100-meter tower up while it's completely bare, you now have to install all the external insulation, the ladders, and the walkways high up in the air. To do that, you'd have to build a staggering amount of scaffolding all the way up a 30-story structure. The safety risks of having workers doing heavy assembly at that extreme height are just massive. Plus, at 100 meters up, severe wind interference makes handling large panels of insulation or metal grating incredibly dangerous and totally inefficient.
So, to avoid this incredibly dangerous height problem, engineers came up with a brilliant workaround known as dress-up. Instead of trying to add components while the equipment is standing vertically in the sky, they literally dress it up while it is safely lying horizontally on the ground. This means installing all the insulation, the metal platforms, the climbing ladders, and the attached pipes right at ground level, way before the big lift ever happens.
Here is how that workflow actually goes down. The dress-up process follows some very structured steps. First, the massive tower is delivered and laid completely flat, horizontally, right there on the dirt at the construction site. Second, scaffolding is built around it, but since it's lying down, the scaffolding is low to the ground and incredibly safe. Third, workers can easily and efficiently add the thick insulation, the fireproofing, and all those heavy metal platforms. And finally, they remove that ground-level scaffolding, leaving a fully customized, ready-to-go tower.
Just take a second to notice the sheer scale of the equipment here. This tower is lying flat, and you can see how the scaffolding completely surrounds the grounded cylinder. Workers have safe, super easy access to every single inch of the surface. They aren't fighting high winds, and they aren't wearing complex fall-arrest harnesses dangling 30 stories in the air, right? They are just methodically applying layers of insulation and attaching brackets while safely hovering just a few meters off the ground. And wow, the incredible transformation is now complete. The ground scaffolding has been entirely removed. You can see the shining silver insulation perfectly wrapped around the colossal structure, along with large pipes already attached to its sides. This massive piece of equipment is now fully prepped, fully dressed, and finally ready to meet the crane.
But here is the critical turning point for the design engineers. Because of this whole dress-up process, the bare equipment weight absolutely does not equal the erection weight anymore. Remember our refrigerator analogy? Well, this is actually the exact opposite. Instead of making the equipment lighter for the final move, the dress-up process has packed thousands of pounds of extra material onto the structure before the crane ever lifts it.
Because of this, a mechanical engineer must completely recalculate the numbers. The new erection weight going into the crane's lifting plan now includes a massive checklist. It's the heavy metal of the bare main body, plus tons of steel platforms and climbing ladders, plus heavy layers of industrial insulation and thick fireproofing, plus the heavy metal brackets, pipe supports, and sometimes even the attached piping itself. Every single piece adds up.
Check out the extensive, multi-leveled platforms, the yellow railings, the wraparound walkways, and the vertical ladders on this fully erected tower. Every single piece of metal and insulation you see bolted on the outside of that structure was attached while it was lying on the ground. It's a really powerful visual reminder that all of those additions fundamentally change the physics, the center of gravity, and the total weight of the lift.
So what does this all mean? Well, it brings us to a very serious reality in plant engineering, the massive stakes of miscalculation. What actually happens if a design engineer gets the erection weight wrong? What if they just forget to add the weight of the insulation, or they miscalculate the heavy steel grating of those platforms? The consequences jump off the drafting table and directly into the real world.
Let's break down these real-world realities. First up, safety. An accurate weight means a stable, safe lift. A miscalculated weight, you risk exceeding the crane's absolute capacity, creating a severe, life-threatening hazard where the crane could literally tip over. Second, cost. These gigantic cranes are rented by the day, and they cost an absolute fortune. If your weight is wrong and you suddenly need a bigger crane at the last minute, you are facing massive budget overruns. And finally, schedule. Finding a replacement crane that can lift an extra 50 tons isn't exactly like renting a compact car for the weekend. It can cause severe project delays lasting weeks or even months.
And that brings our narrative back full circle to the true moment of truth. Listen, you can do all the math in the world. You can build the most beautiful spreadsheets and run the most advanced modeling software. But the crane monitor never lies. When that massive diesel engine roars to life and the lifting cables go tight, the digital display in the operator's cabin will reveal instantly if the engineering math was perfect.
I want to leave you with this provocative thought to ponder as we wrap up. How does preparing for one single, fleeting moment of lifting dictate months of incredibly detailed engineering and assembly on the ground? Mastering the concept of erection weight isn't just about knowing how heavy a giant piece of metal is. It is the ultimate lesson in Project Foresight, showing us exactly how seeing the end of a process entirely shapes how we have to begin it. Thanks so much for joining me on this explainer. Keep asking those great questions, and I'll catch you next time.